Good day to you all. You are welcome to today's lesson. Today we are having a problem on differentiation, which is find the derivative of a function f of x equals to x using first principle. Now, what do you mean by first principle? When finding the derivative of a function using limit, we call it first principle. So derivative of a function using limit is called first principle. Now, and before you do justice to this, let's take a recall on some facts under limit. If we have lim f open bracket x plus delta x, which is change in x, minus f of x, all divided by delta x, as delta x tends to 0, that is the denominator tends to 0, the limit of this, the whole of this expression is going to give us f prime of x. So anytime you are finding the limit of this expression as this denominator or this delta x tends to 0, is going to give us f prime of x. The another fact is lim k as the limit of k represents a constant, as x tends to 0 or whatever number that it tends to 0 is going to give us what? The constant k back. So the limit of any constant as the variable tends to 0 is going to give us what? The constant back. So having understand these facts, then let's now come to the solution. We have f of x equals to x. Now, to find this derivative of this using first principle, the first thing you need to do is to add change in the variable. And the variable you are dealing with here is just only x. So you add your change in x, which is denoted as what? Delta x, which simply means increase or decrease. That is, increase in x or decrease in x. Because as one variable increases, the other will also what? Increase. And as one also decrease, the other will also what? Decrease. So we use this delta x to represent change in x. If it is delta y, change in y. But because the only one we have, the only variable we have is just x, so that's why I just put only, I'm going to have only delta x. So I'm just going to have f open bracket x, add your change in x here, we are going to have plus delta x equals to, then to this other side, x plus delta x. So once you have added your change in variable, the next thing to do, which is the next step to do, is to subtract your what? Function, which is f of x, from both sides. Subtract your function from both sides. Our function here is what? F of x. You subtract it from both sides. And why are we doing that? So that this first term can terminate. So we now have f open bracket x plus delta x minus f of x. Then the other one becomes x plus delta x minus f of x. So that's the next step. Subtract your function from both sides. Our function is f of x. If it is y, subtract y from both sides. So here now, you have f of x, so that they have subtract f of x from both sides. So the next thing to do now is to replace the value of what f of x in the word right hand side. Replace your value of f of x in your right hand side. So f open bracket x plus delta x minus f of x equals to, you don't replace it here. This is the letter. What you have this is majorly is this right hand side. So you have x plus delta x minus, what our f of x for the question is equal to x. So f of x equals to what? X. So I have replaced that. Then this cancel this. So the next thing to do now is to write the remainder f of x plus delta x minus f of x equals to delta x. So we are, after minusing this, we are left with this. So what is the next step again? The next step, once you have subtracted your value of f of x from both sides, we have replaced your value of f of x in the right hand side. The next thing to do is divide both sides, the entire expression by what? Delta x. Divide the entire expression, that is both right hand side and the left hand side, by delta x. And that will give us f open bracket x plus delta x minus f of x delta x equals to delta x divided by delta x is given 1. So after dividing the equation by delta x, the next thing now, which is the last thing to do, is to take the limit of both sides. That is the major concern of what? First principle. Finding the derivative using limit of a function. So once you have divided both sides by delta x, the next thing to do is to take the limit of both sides. And that will give us limit of this as delta x tends to 0. Likewise here, lim 1 as delta x tends to 0. Now, from what I explained at the beginning, is that the limit of this whole function here, which is limit of f open bracket x plus delta x minus f of x, all divided by delta x, as delta x tends to 0, give us what? F prime of x. That is the fact. So then limit of 1 as delta x tends to 0. Don't forget I said limit of a constant, lim, when x equals to 0 is still k back. So the same thing here, the 1 here represents k, which is constant. So the limit of any constant, irrespective of the constant, will give us the constant back. So the limit of, because there is no delta x in this expression where we can replace what? The value of a delta x. So the only thing we just have there is just constant. So the value of this will give us what? 1. So therefore, the derivative of this function, which is f prime of x, equals to 1. That is how to find the derivative of any function using first principle. Bye bye.